Good morning, guys. Welcome back to math. This week you're going to do the cumulative review from topics 1 through 8, and this video is just meant to refresh your memory on how to perform some of the things that we've learned already this year. First, you will be asked to make estimations. There's 3 strategies I want to review with you. The first is to make a magnitude estimate, and that is just to the highest place value when you make a magnitude. So 622 would be thought of as 600, and in 45 you'd round that to its highest place value, which is the tens. So that would become 50. 6 times 5 is my basic fact, and I have 3 zeros that I'll add at the end. You could also, when using decimals, just simply round to the nearest whole number. The whole number is your ones place. And I look here, there's a 9 to the right of my 5, so I'll think of that as 36, and 5, and 20. To estimate, 36 plus 5 is 41, plus 20 makes that 61. You could do a magnitude estimate there if you wanted. It simply would become 40 plus 5 plus 20, and you see that's still about the same value. They're very similar estimates. Another strategy is to make a friendly fact if you can. So if you're dividing here by 92, I would round that to 90. And then I want to look to change this number to be a number that 90 or 9 is compatible with. You see 72, 720, right? So I'm going to round 719 to 720. I'm going to think of 72 divided by 9 being 8. So 720 divided by 90 is 8 as well. The next thing we're going to review is adding and subtracting decimals. We remember to line up your decimal point. But in this expression, 3 times the quantity of 5, 3.5, 3 plus 1 and 77 hundredths, there's parentheses, and you must follow order of operations if those parentheses are there. So you're going to add your decimals first. And 3.5, I'm going to line up every number under its correct place value of the number above it. I'm going to go ahead and annex a 0 here to make it even. That's a helpful strategy when adding and especially when subtracting decimals. Then you're going to add it and bring your decimal right down, and it's that easy. The next thing I need to do is, once I have that sum, I'm going to multiply it by 3. A quick estimate tells me that's about 15. Well, 3 times 7 is 21. 3 times 2 is 6 plus the 2. And 3 times 5 is 15. Well, I know my answer isn't 1,581, but my estimate was 15. And also, to place a decimal in a multiplication problem, you count the decimal places. There are 2 decimal places in my whole problem, so there'll be 2 in my answer. Multiplying decimals, you count the decimal places. So if you're looking at this problem, how many decimal places will it have? 3 is absolutely correct. Good job. For division, you're going to set up the problem, and I need you to think about the remainders that you might have if the problem calls for it. This one does not. It says, at a school, 294 students are going on a field trip. They are put into groups of 14 each. How many students are there? Enter the whole number in the box. So, this is not a division problem. Oh, how many students are there in the group? Oh my gosh. It is 294. Oh my goodness. And dividing by 14. And it works out that 14 cannot go into 2 but to 29 twice. And 14 times 2 is 28. Bring down my 1. Drop the 4 down. 14 and a 14 one time. How many groups of students are there? That was what I didn't read. And it is 21. I have no remainder here. 1 times 14 is 14. I'm all set. If I did have a remainder, what I mean by interpreting that, you might have to think, do you round up? Do you add another group? When you're dividing decimals, just simply place your decimal above where it is in the problem, right in where it would be in your quotient. And then you divide as normal. Okay, that easy. Sometimes you will have to annex a 0. Before I place this decimal up, I have one decimal in my divisor. I'm going to multiply that by 10 to the first power. Move my decimal once. I must do that here in my quotient. Okay, so I'm going to do it in the dividend to match it, and I place it right up in the quotient. Now I can divide. 15 goes into 60 4 times. I put that 4 right above the 0 here. 4 times 15 is 60, which has 0 remainder, so I'm going to bring my 3. Can 15 go into 3? No, but I'm not done dividing, and I don't want to have a remainder in a decimal problem. I need to say 15 cannot go into 3, but let me go ahead and now annex a 0 after this decimal point so I can continue to divide 15 into 30, and there you go. That would be how you solve that one. So would you try this one? Which 2 would you choose? That's exactly correct. If I'm telling you that this problem is greater than, that means a 4 in the tens place has to be greater than the numbers you chose, and that's why those are your 2 answers. Be familiar with number and word form. If Isaiah is thinking of the number 9 and 52 hundredths in his head, which of these has the same value? Write them out. 9 and 52 tenths. Well, I just said, as I wrote it, 52 is in the hundredths place, so no thank you. 9 plus 5 tenths plus 2 hundredths. Yep, that works. 9 ones, 5 tenths plus 2 hundredths. Yep. How about 9 times 1? Yes. 5 times 10? 1/10. Yes. And 2 times 100th. Yep, that works too. 952 tenths. Nope, because that is 100th. So 952 hundredths is how you would solve that. Go through each one individually. Please remember that in place value, each place value place is 10 times the value of the one to the right. Oops, I have 2 rights there. Each digit is 1/10 the value of the digit to the left. So that just means that in standard place value, when you have the hundreds, the tens, and the ones is 1/10 the value of a 10, and 10 is 1/10 the value of 100. Going the opposite way, the hundredths is 10 times the value of the tens, and the tens would be 10 times the value of the ones. If there was a decimal and I had my tenths here, the ones is 10 times the value of 1/10. So in this problem, I have 5 tenths and 50 in the place values. They're 2 place values over, times 10 times 100. The 5 in the tens place is 100 times the value of the 5 in the hundredths place. How many times greater is the value of 4 in 547 than the value of the 4 in 84? Enter it below. That's right. This 4 is worth 40. This is just 4. That is why it is 10 times. Good job. You try this. What is 1/10 of 4? Dividing 4 by 10 or taking 1/10 of it? Excellent. How about this? Which expression is equivalent to 10 to the 4th power? Yes, that would be a 10 with 4 zeros. 10, and then I have 4 zeros. A 1 with 4 zeros. It's 10,000. Nice. Adding and subtraction of fractions requires a common denominator. when you're working a problem like this is just a visual model. So if I asked you to add this, it'd be 1 plus 1 plus 1 plus 1/4 plus 3/8, because this told me this was one whole. Well, the whole numbers are easy to add. Let's do our fractions first. 1/4 plus 3/8 requires a common denominator. I hope as I'm writing this, you're already thinking that I could use, 8 as my denominator, because 1/4 is 2/8. So 2/8 plus 3/8 gives me 5/8. And then I have 1, 2, 3. That's why the sum is 3 and 5/8. If Kim's cookie recipe requires 3/4 of a cup of brown sugar, and she has 1/4 of a cup, how much more would she need? Indicates a subtraction problem. So let's go ahead and set it up. I'm going to use 4 as my common denominator. 3/4 minus 2/4 tells me it is 1/4. If you're adding and subtracting fractions, I like writing them vertically. It makes your work easier to show. And a quick way to find your answer is a quick common denominator of multiplying the two together. So using 20. 5 times 4 is 20. 1 times 4 is 4. 4 times 5 is 20. 3 times 5 is 15. And then you add. Same thing with subtracting. 8ths and thirds. I need a common denominator. I'm going to use 24, because that's what 8 times 3 is. 8 times 3 is 24. 7 times 3 is 21. 3 times 8 is 24. 2 times 8 is 16. 21 minus 16 is 5, and my denominator stays the same. You do that if you're doing mixed numbers too, except that you would do fractions first always. Let me show you this mixed number fraction problem. Let me set this up correctly. 4 and 2 ninths minus 1 and 2 thirds. What denominator can I use? 3 and 9. I'm going to stick with 9s. So 2 thirds, 3 times 3 is 9, 2 times 3 is 6. This is my problem. 2 minus 6. I cannot do that, but I know that I have 4 whole numbers here. So if I think of 4 instead as 3 and 9 ninths, then I could go ahead and add the 9 ninths that I have here to the 2 ninths I have here already. So 9 ninths and 2 ninths make it now 11 ninths. 11 ninths minus 6 is 5. Keep my same denominator. Whole number subtraction, 3 minus 1 is 2. If you're multiplying a fraction or finding a fraction of a number, that's multiplying, which is numerator times numerator, denominator times denominator. If you're multiplying a fraction by a fraction, the answer could have a different outcome than you may expect. So in this case, I'm using 3/4 every time. So I'm comparing how my answer is going to relate to 3/4. If I'm multiplying 3/4 by 1/3, I'm taking a third of 3/4. I know my answer will be less than 3/4. If I take 3/4 and I multiply it by 3/3, which is equal to, 1. Well, then that will be equal to 3/4. If I took 3/4 and I multiplied it by a fraction that was more than 1, 5/3, 3/4 and I'm multiplying it by technically 1 and 2/3, my answer will be greater than 3/4. But if you multiply by a fraction, your answer could be smaller if it's a fraction less than 1. This is a fraction of problem. If Franklin has a bag of 24 gumballs, there are red, blue, and green gumballs. I'll make that all nice and pretty for you. The The question is, how many gumballs are green? But first, to solve it, you have to look at the number of gumballs that are red and blue. Well, if 3/8 of them are red, you could do that mentally. You could think, well, 1/8 of 24, and then multiply that by 3. Or you could take 3/8 of fraction multiplication, 24. 3 times 24 is 72, and then 8 times 1 is 8. Well, 72/8 is like 72 divided by 8. There are 9 red gumballs. If 5/12 of the gumballs are blue, 5/12 multiplying of 24. Do you remember we were starting to do some simplifying first before we actually multiplied? Both of these fractions are in simplest form. However, I could reduce this fraction because 12, this denominator has a common factor with the other opposite numerator. I could divide each of those by 12. 12 divided by 12 gives me 1, and 24 divided by 12 gives me 2. Makes it a much easier math problem because now it's 5 times 2, which is 10, over 1. If I did 5 times that, it would have been, 120 over 12, which would not have been difficult to solve. It still would equal 10, but it makes it a little easier to work with smaller numbers. So in his bag of gumballs, 9 are red, 10 are blue. How many are green? Yep, there are 5 green gumballs. Good job. The last thing I want to do here is remind you how to multiply a mixed number. We want to write it vertically again, just so we can easily change my numbers, okay? And then I'm going to multiply. But we do not want to just multiply your fractions and your whole numbers. So we need to make these improper fractions. To do that, you multiply your whole number by the denominator. 2 times 5, that's 10. Add the 4. That becomes 14/5. And then 3 times 1/2, you say 3 times 2 is 6, plus 1 is 7. So this becomes 7/2. You can multiply straight out, right across. That would be 98 over 10. Or we could simplify first. 2 and 14 can both be reduced by 2. 2 divided by 2 is 1, and 14 divided by 2 is 7. 7 times 7 is 49. 5 times 1 is 5. 49/5 is the same as 49 divided by 5, which is 9 and 4/5. I felt a sneeze coming on, but I held it off. 9 and 4/5. And that makes sense to me because of my estimate. 2 and 4/5 is very close to 3. And 3.5 is very close, if not, it is more than 3. So 3 times 3 is 9. My answer should be more than 9. So it works. It makes sense. Now, we're done with my review. I have a resource page for you. It has visuals of reviewing your skills, and it also has some study guide links. Please use those as you do your review because it's important that you do your best. I'm proud of you.